Okay, well, good afternoon, everybody. Welcome back. Thanks for coming back. We think this afternoon is really going to be great. I'm really excited about this next couple of speakers. Many of the school districts in and around Kansas and Missouri have been engaged in what we're calling deep learning. And oftentimes that's project-based learning or work-based learning. Some use the coin or have used the coin term real world learning, and that's immersing students into situations where they're more work-like. And so that's what these next couple of presenters are going to talk about. First, we're going to hear from a combination tag team, if you will, from Train, a longtime partner, and Beloit USD 273. We've got a panel of school administrators from Beloit here to talk about the PBL-WBL partnership with Train and the success stories that they've seen come from that. I'll also tell you that later on, or in conjunction with this, Kevin Ward and his team from Train will talk about how they integrated their work. The great thing about these kind of relationships is it is a win-win situation. And if the students get the real world deep dive, if you will, training that they really need, and at the same time, business and industry can benefit from the relationship as well by finding really high quality, high skilled employees to fill the positions that they have open that coincidentally happen to be high wage. And then after those folks have concluded, we're going to have Susan Wally and her Prep KC team come on, and they're going to talk about something very closely related, and that's their connector model. So I think you'll find that very valuable as well. So let's kick it off and hear about the Train Beloit partnership. Thank you for coming.
Welcome. My name is Jeff Travis, and happy to be here and talking about our partnership with Train. Some of you sometimes ask why this project and why this partnership, and why has it been so successful? First off, we are a Gemini 1 school that has really taken this process and ran with it. Our faculty, staff, and students are really proud of the changes and really take it to heart. That dirty word KISA that we all go through in Kansas with accreditation, we just married the two together and put redesigning KISA together and keep going through this process. And relationships and relevance are the two keys to what we look at all the time when we're doing anything, is what kind of positive relationship are we making, and is the learning relevant. So as we talk about this partnership, you're going to hear a lot about that and the results that have come out of that. This partnership really allows us to focus on these goals, and as we continue to work on our own school physical change as well in these goals. Beloit likes to talk about education being a verb, not stagnant. It's not a stagnant noun, it's an action plan, an action verb. And we kind of stole that from Dan Whistler, who you're going to hear from later, talking about how science is an action. And so we like to take that twist and talk about our education being an action and not being stagnant. We pride ourselves on being a student-led district. I know Casey and Brady will talk a lot about how we're student-led. Every year I try to meet with the Stuco once or twice at least. And back 3-4 years ago when I was talking to the Stuco kids, I said, what do you want and what do you want to see and what do you want changed out of your school? And there was 2 resounding things that came out of that conversation. The buildings are uncomfortable, and they wanted more STEM, specifically engineering things added to the curriculum. And this is coming out of the students' mouths. This is what they wanted. So we joined with, I went to talk to Kevin Ward at a KSB conference, and we sat down and we talked about this. And when I say we, I'm saying meaning Train, my admin team, my board of education, and my students. We put the students in charge of this change and let them lead the cause. As we did this, the students used our buildings. And I say this buildings is plural because there's elementary students doing this as well as junior, senior high school students. And they took the data and they analyzed it and they put a plan together and they proposed these changes to the board. There was help from admin team or teachers, there was help from training, but they went out and they proposed it to the Board of Education. And many of those changes have been made already. And Stuco came back into our board meeting and thanked the board for the changes because they're resounding changes in the environment and what's been made to those environments in just in the classrooms. You will hear today how our students turn our campuses into living learning labs. They did the data analytics, they proposed the changes were made, and they're still making the changes, and the students are making the changes. I mean, we joke about, and Casey will talk about this, and probably Brady as well, sometimes the students don't know how much in charge they are because we let them lead charge on this and do this. And it's hard to tell them no sometimes too, especially when they have the facts. The analytics are always being conducted on this, the physical change and the future changes, or the present changes and the future changes. We've accomplished many things from this initial meeting of just sitting down with our students and kids and asking them what do they want. I don't know a better way that we could have brought this redesign effort and a business and industry partnership together and made a bigger impact on our students and our faculty and just frankly our campuses. I go back to a story that I've told many times, but we had a student come in that and applied to come to Beloit from a neighboring district. And I really wanted to say no because I always see those applications, and Casey talked me into saying, he said, let's take her, let's give her a chance. This is a kid that had bad history. She's fighting, grades were D's, F's, mostly F's, poor family. Just, I didn't know what she was going to bring to our school climate, frankly. And Casey and his team worked with her, and she got into the BTU crew, became very successful with the BTU crew. In fact, KSB was doing their leadership group on one of our campuses at the high school, and I walked in to watch, and she was the main presenter, and I couldn't believe it. And she talked with passion. She knew what she was talking about. She talked about the change. I mean, she was adamant about what she was talking about and what she's learning. Grades changed immensely because of this, because she had a cause. She liked what she was doing. I believe she's now working with some energy fields out now that she's graduated. And so just another way that the learning became relevant and those relationships were important. You know, we talk about rigor, responsive culture, but the results were accomplished. I'm going to pass it on to Casey and Brady as they talk about this and let you know a lot more in detail of what's going on.
Hi there, I'm Casey Cipher. I'm the principal at the junior senior high school, and we're going to go over kind of our path and our direction, where we started and where we ended, and how it was really a snowball effect for how it all went down. And so from the first time that the kids went to the education center, we have an enrichment program in the summer, and we went to train, and when we went there, the kids, and these are 5th, 6th, 7th, and 8th grade kids, and they came back talking about it, like, how can we do this? And that was about the time we really started pushing, hey, we can add this to the school day, and we had a STEM class, but we didn't know which direction exactly to take it. So this really, I'm going to say, gave us a path to go on. And since then, we've really, I'm going to say, jumped all in. And from the junior high level and the high school level, those teachers collaborated daily. But then the elementary teachers, we have STEM from preschool all the way up. So it's probably our most solidified program, K-12, in terms of we know exactly where they're going to be. And so now when we're getting kids into the junior high, they come from the elementary school already having that foundation. So I think it's huge for us. And we've been involved in some Kid Wing challenges, the NEED project, other things that have, I'm going to say, just happened because of the direction we started in the summertime.
I'm Brady Dean, the elementary principal. And one of our when we went through redesign, was to focus on those high wage, high demand, high tech fields of study. And then also at the elementary school, we were heavily focused on project-based learning. And this project really fit right into what we were trying to accomplish there, where the kids could jump right in and analyze the data from their buildings, do different projects related to this. It was hands-on learning, and it really, really sparked student interest into these types of fields. And we have an elementary STEM teacher, and that we made that one of our specials rotations through our redesign process. And that's what Casey was talking about having that vertically aligned curriculum from preschool clear up to our high school level. And it's a seamless transition as they go, where we introduce several concepts and then they take it to a whole new level when they get to that junior high and high school level.
Thank you, Brady. I'm going to jump in and give a little bit of background here. I think it'll be important history. So this all started in 2011 in Kansas with a Board of Regents and Commerce and Train and MC3 strategic public-private partnership, and that resulted in a couple high-tech labs at Washburn Tech and WSU Tech. That was the first part of a strategy, and then MC3 came into play. This is, again, just a quick overview of a corporation education partnership, public-private partnership model that's focused on industry recognized certificates to build that next generation workforce. You see it's grown significantly. Train was the second partner along with Snap-on back in the beginning, and you can see the number of corporate leaders as well as the growth of the leadership schools and certification centers. Just a quick overview of the certifications across high-tech, high-wage, high-demand fields, aligning with what we're trying to do comprehensively with our education and business partnership model. These are a couple of these labs here. They're modeled after what we piloted at Washburn Tech. Those were the two that we put in Kansas. There's now been 22 other ones put in across the country based on that model. In 2017, we had the great opportunity to visit with Commissioner Watson, and he asked us to join the effort of the Kansas Can redesign effort. So that allowed us to start working more with the secondary partners. Of course, some of you might remember that in 2017, we were in front of this same audience with this model for business and education partnership. For my Missouri friends, DESE approved these IRCs in 2018. We built out the PBL, WBL analytics curriculum in collaboration with KSDE, and then we hired Dan Whistler, the part of our team. We just couldn't do it without Dan, a tremendous asset for us and for, I think, the school districts. 2018, we then had the opportunity to pilot, and the Beloit schools was the first, but right behind them was Leavenworth, Dighton, and Caney Valley. 2019, again, on the Missouri side, we continued our alignment with Commissioner Mulligan and her team. We're going to hear later on about the data analytics certifications that we started to develop here a few months ago. Again, on the Missouri side, we have plans underway with State Fair and North Central to have labs on the Missouri side. Exciting news from WSU here a few weeks ago that they invited Train to be on the board of the National Institute for Digital Transformation. And then a whole lot of things will come out of this Google arrangement as well. Dan? Dan, are you muted?
I'm unmuted. Yeah, Dan Whistler, science teacher for 33 years, highly involved in energy education the last 10 or 12 years. Love the study of energy. Just like we can talk about human blood moving through the body being vital for life, energy literally is the lifeblood of our society. So through the BTU crew, we take students all the way through career awareness, an introduction, where does electricity come from, for example, and here's from a career standpoint, the opportunities that are out there for the students as they learn more about energy in our society. We can't train our electricians fast enough, for example, all across the states. One of the things I really like about the BTU crew, Casey mentioned it earlier, science is a verb. It's not just learning science trivia, it's actually students that are doing science. And then a key part of it is they aren't learning it to take a test, they are learning it and sharing what they're learning with others. One of the best ways to learn something is to teach it to somebody else. And when we start doing these things, again, the students take ownership of it. It's been fun for me to work with the Beloit district. I'll let Casey and Brady share a little more on this slide about what they've done implementing it in the redesign process, and then I'll follow up with a little more. So Casey, Brady, go ahead.
All right. Obviously, everybody has to be accredited, and so when we looked at our KISA and we're looking at accrediting, but we're also looking at redesigning our school. It happened to be, and we always talk about the perfect storm. We were looking at both of them the same year, and we really wanted to change some things after talking to our students about what do you need and what do we need to make your education better. Dr. Watson talked a lot about student success skills, partnershiping with the community and going on personalized learning, the real world application. Like, that is what we wanted to do, and the state's pushing it. We have to do KISA to make sure that we hit our accreditation. And so I know Mr. Travis talked about marrying the two, and so we did, and it was pretty seamless, where we said, you know what, we're going to focus on this, but we're also going to focus on how do we change the education in our building to make it hit the student success skills and the real world application. So from the high school in the district, we're looking at partnerships with corporations so that we can get certifications. We're looking at real world. And so we've added a coffee shop business, and we've added some of these other things that we're saying, okay, that's a real world application. But the biggest aspect of change has come from, okay, we're going to partnership with train and our local buildings, seeing what can we change to make the education for our kids better. And that was the first thing we asked, like, what don't you like? And it's not comfortable here. How do we change it? So we are set up for a pretty good system on we needed a change. At the elementary school, they were looking at a few things. I'll let Brady talk about that.
Yeah, you saw at the bottom of that slide there, circled PBL and STEM. Those three things at the bottom there, those are our main areas that we chose to focus our school redesign efforts on. And that middle one, PBL STEM, was a huge one, to the extent that we hired a full-time STEM teacher and just wove it into our specials rotation. And then we started bringing our grade level teachers on with project-based learning. And with this partnership and the BTU curriculum, this really helped us achieve that real world application, that the students could actually look at data from the classrooms that they were sitting in, the heating and the cooling and the air quality. And so they could say, yes, this is Mrs. Pruitt's room. And yes, it shows that it's hot here, but we know that because we're sitting in that room. How do we make that better and things like that? So it really brought this abstract learning of heating and cooling and energy to how do we make this more comfortable, and it's going to benefit me, and it's a real world application right there in the elementary building. And so it's just, without this partnership, there's no way that we could have replicated this, because of the high-tech sensors that they brought into our building, the analytics software that they brought to us. We didn't have access to that without this partnership coming in.
So I'd say that's probably the biggest thing. And with our STEM program, we now have a standard curriculum that we're going to follow. And as we go through, we're going to talk about Kid Win and some of those. And so we have multiple curriculums. So now if you come into a STEM class, it flows and it starts and it progresses the way we want. So that's really nice about the BTU crew curriculum as a whole, and the fact that our building needed all these changes. It really did go hand in hand to help us change. And when we go through, so this is our building, and we've changed it so much. And I know it looks like just an old gray thing, but on the inside, it's definitely it's doing well. And so we're looking at heating, ventilation, all of that, because we were not on a good system. Like, one room might be 92 degrees and the room right next to it might be 65. There was no consistency. And so we're trying to figure out, like, how do we just get everything balanced and aligned? So we put the sensors in, and then we turn it over to the kid and said, what are your thoughts? And the kid said, we need a sensor in this room, and this room, because they are so just fluid. There was no consistency, and it might be from 1 hour to the next. So our kids helped us on that. And our kids also reached out to the city to learn. And I think that's one thing that sometimes we actually overlook. We were looking at this is our energy usage, this is our bill. We have 12 times that we looked by our monthly billing, and with Trade's help, they said, you know, you can get a breakdown of that every 15 minutes. Well, we didn't, but now we do. And so if you look at the graphs on the bottom, our kids instantly said, oh, we can see all kinds of stuff. Why does it spike at this time? Why is it changing at this time? So that's incredibly important from an educator's point of view. If you can analyze graphs and data, you can do well on the ACT, on the science portion, because that's the majority of it. So it did, we can say cross-curricular a little bit, but not only from a STEM and data analytics, but like we want our kids to score well on the ACT so that they can get money for college. I mean, it's pretty self-explanatory on that. And so we start looking at, okay, how do we analyze? And now we've got this data, and now what do we do with it? What changes do we want to make to basically improve our facility? And so that's the next steps that we've really been taking is to look and analyze, and then, okay, now what's the future? And kids don't have a checkbook. They just assume we can buy whatever we want, but we have to make those best choices. And then unfortunately, Mr. Travis shuts us down sometimes when we really want to put in skylights in every classroom. However, they then start looking at, okay, what can we afford, and what's the most cost effective? So that's really where we've gone and how we've changed since then.
As Casey was describing there, one of the things I really like, again, it's project-based learning. When you study energy, it's across all the different subject areas. And when it's experiential learning, when students are sharing it, they're working as a team, they're sharing what they're learning, again, it goes far beyond content. So it really hits all areas of career preparation, life skills, essential skills. And that's been, again, a critical part of the BTU crew as I work with students. It was fun for me this morning as I listened to Dan Rockwell. He shared purpose inspires connection. And that is really what this slide is all about. As I work with school districts, we identify, okay, what's the purpose? There's two different grade levels, again, 4 through 7, 8 through 12, or more specifically 8 through 10. So the career awareness, career exploration, the opportunities to share both locally in the community or statewide conferences. Maybe it's even to set the goals to compete at a national level. In February, NSTA came out with a new position statement on STEM. And I love, you read through this position statement, it ties into exactly what we're doing through the BTU crew. It's experiential learning, it's interdisciplinary. One of the things we're working on with KSD, there's a new Intro to Energy course. So how do we integrate a more in detail study of energy as part of our science classes? So you start looking at it from a life science standpoint. Obviously, you can study the flow of energy with food. Now we can do the same thing as far as where our electricity comes from. So Casey, Brady, if you'd like kind of take us through the timeline of what you've done in implementing this in your schools, please.
You bet. So we go back to putting sensors in the school. So that's May of 16. And as we walk forward, I mean, it's 2018 and we're thinking, okay, we're going to like slowly get going. We hammered down. We took off and we took off because the teachers had a few ideas and they ran with them, and the curriculum that they were given and the ideas, the kids, I don't want to say you couldn't buy in anymore. So it wasn't a tough sale for the kids because kids said like, this is really good stuff. So this kid and this wind energy, kid wind. And so we're looking at that. We have Jason Raby, who's our city manager, and Scott Schreiben, who's the energy consultant. They come and they talk to our classes, and all of a sudden our kids are saying, no, wait a minute, these are local people from our community, and they are saying we can do this. What if we show them these ideas? And so our kids really tried to keep it local then and go from there. You can see some of the different kid wind designs up there with the different just propellers, and you'll see them as we go. The pitch and the fan blades and all of that, and it became a competition within the school. The guys in the middle are high school kids, and they're very engineering based. Like they are farm kids who make their own machinery. Sometimes they are very, very I'm going to say immersed in the idea, and their machine they thought would be the best. We go to some competitions, and they get beat by some young ladies who don't have that agricultural background, but they said, well, if we change this, and so it did become a competition. our junior high kids in the top left there continued to adapt and continue to adapt. And one of them is my son, so I can talk about it a little bit, being a goofball. But he said, we're going to make these shaped like feet. And so their initial blades were like Bigfoot. And what they realized is, hey, this might not be a bad plan. And so then they started tinkering and tinkering. And then the plan changed so many times along the way. They found out how to take the grease out of bearings. They found out how to make it more efficient, little things like that. And one of the best things they found is how to present, because they presented to our Board of Education, they presented to a Council of Superintendents. Every competition they had to present to judges, and they had to know the answers. They couldn't just wing it. And they also had to be able to present in a manner that, you know what, I can have a conversation with you and you can answer it. And so it really, really helped us to expand the program, because they would come back and say, this is awesome, we're doing this, this, and this. And the kids had to be on their A game. And so for junior high kids to present to a Council of Superintendents and at major presentations, I mean, they were, I'm going to say the keynote several times to present to the Board of Education. They didn't know any better, so they weren't nervous. Afterwards, we kind of talked to them like, do you know? Oh, I probably should have been more nervous. So I think that's a life skill that we can't do anything but enrich over and over. We also had an energy expo. And so for STEM to grow into, hey, we think we want to do this, to by the end of the year, we opened up our school to the community and said, we want you to come see all the cool stuff that we're doing. And so we do have elementary kids all the way through high school kids who are presenting to community members saying, like, this is what we need to happen. And why do we want solar energy? Why do we want LED lights? And so just the different changes in how they want to go. With the wind energy specifically, we have Cloud County, which is 30 miles away, but they have wind farms all over right there. We sent kids there to go on tours, to develop information, and they gave us, you guys are really taking off on this. And so they also realized, like, there's a career in this. And so the career exploration was fantastic. We had it with students that didn't know what they wanted to do to go to college, and instantly, like, they went into wind energy, and they're making more than I am right now. And so they graduated 2 years ago, because that field is growing so fast. And when looking at that field, they really are understanding it. So solar energy is just, I'm going to say, a very untapped resource for us. We got the solar panels put in, and it was the 1st of March, and then we went on vacation the rest of the school year. And so we're starting up right now, and we were very excited about it, but just analyzing how much energy we get from it. And instantly the kids said, like, we need to put these on our entire roof, and let's go from there. And so these are some of the different designs, and this is a team of girls who really took off with the project and started understanding what pitch meant. And it's interesting, when you would go on bus trips, they would now look at the turbines, and they know, like, well, our turbines have 3 fan blades because cost effectiveness. We can either put 4 on there and develop a little bit more energy. However, it costs X amount of dollars more, and it's going to take 15 years to recoup that cost, as opposed to 3, and we're going to make more money right off the way. So just the conversations that our kids are having, and how much they really dove into it, it has been maybe the best part. And so our Kid Win Challenge results, we go to Manhattan at regionals, we get 1st and 2nd, and then we go to state and our junior high team. But their growth from regional to state was exponential. And so when we first tried it, and we had the class test to see who would get to go to regionals, I think they were getting 10. When we went to regionals, I think we got 22 to 28. When we go to state, we're over 50 and 60 joules being produced. So every time they redesigned it, they said, okay, we're going to make this better. And you can see on the bottom left, their final blade setup much different than what they started with. And they realized, like, okay, the cost is not a barrier in designing this little fan. How do we make it work? And so they went there. When they go there, they have to create one on the fly. And so just the deep thinking and looking at all of the different analytics has really been fantastic. So they're reading the amount of joules, and so they're going through these graphs on their computers, and they're 8th graders, and they're saying, like, oh, we need to do this to get better. And it didn't cost us a whole lot of money, you know, an initial small investment, and small, like $250 to get it going for a program that took us to Washington, D.C., a program that took us to Houston. And the great thing about that is it was, hey, National Energy Education Development Project, like we're trying to come up with this. You guys are National Senior Rookie of the Year. You want to go to Washington, D.C. We don't have the funding for that. They fundraise, and we had about 15 kids raise $20,000 in less than a month. And it was all, you know, they sent a video out to wind farms, and people would say, like, that's really good stuff. And the wind farms sponsored us. So I think that was one direction that we took that has been, it's a staple in our school now. We have a wind energy scoreboard that's permanent, just like we have record boards for sporting events. So it is there. Now, on the flip side of that, the energy analytics, and what we're looking at is, okay, this is our building, this is actual money, and this is information that we can see, hey, that light's on, why don't we turn that light off? Simple things that our kids are looking at, and so they're analyzing what is going on with our building, why are we spending so much money at this time, and also how does billing work? The fact that if you have a spike, it's going to cause you to pay that the whole day. When we look at our install and our sensors, we went to rooms where kids identified there's an issue where they needed more oxygen, more airflow. And so we've changed that and we've put it in. And it's been because our kids said, these rooms are bad. And bad's are relative, but these rooms are unstable. And so we've really fixed, I'm going to say 15 rooms, completely revamped them and re-altered, and we got to put in last, it would have been in December, January. And one of the interesting points was our student council vice president at the time came back, and it was about early to mid-February. She said, I don't know what you guys did in the rooms over Christmas break, but they're way better than they used to be. And so that kind of feedback, probably just as important as anything else we have in terms of, we get information from the students, we use it, and then they notice that, hey, you guys are listening to us, and that's the change we're going to make.
Thanks, Casey. I'm going to have my colleague, Chris Torline, an engineer, join us now. Chris.
Hey, good afternoon. I'm with Train, an engineer, and I currently work in our data analytics division, what we call intelligence services. I had the opportunity to work on developing these NC3 data analytics certifications. This article from CNBC this summer spoke about the top skills that every future worker should master right now. Number one, data science, followed by communication and creativity. These are the foundation of why we felt important for these data analytics certifications. People often most think about three careers: data analyst, data scientist, data engineer. That's not the only careers that involve data analytics these days. It doesn't matter if you want to be a climatologist, a criminologist. I'm an energy engineer. I use data analytics, and the team I work with do every day. Real estate, and so Forbes has been had a couple of articles out. Here's one that's 30 data analytic careers that are not data scientists. Number 7 is a nurse. Number 16, a plant breeder, right? Agriculture. And I like the title that this author gave themselves, right? I decode analytics for business people. So the first certification focuses on all these careers that they get to analyze data. Florence Nightingale was a nurse 150 years ago who's credited with creating the very first data analytic visual chart for the purpose of creating change. What she noticed was that soldiers coming to her hospital with wounds were not dying of war wounds, but were dying from preventable diseases, dysentery, infections. And so she created these charts and explained to her hospital administrators, to military personnel, hey, we need more mops in the hospital, and we can, and she's now credited with saving countless number of lives. This is what we're talking about. And if we look at current technology and software, this is an example here. We won't click on it in the interest of time. That really the data analytics with life expectancy, this particular chart compares it to income in every country of the world. It's really powerful what we can create these days. Here's another example. This is called a dashboard. This is a one page, it's got 3 or 4 charts on it. This one's of Kobe Bryant's career. This is created in Tableau. This is what a student would create, something similar to this in our first data analytics certification. Effectively take a data set, create something, tell a story, be creative, explain it to folks, right? Just as you heard Casey explain how important that was for his students, that's the foundation. From there, we start to use the building as a living learning lab, and we analyze data analytics using some trained software, even using live data in buildings, that we can really get the students involved with their own building as a living learning lab. These are a couple of charts, examples. It compares weather so that when students see things like a chiller cycling on at night, is that necessary? Why is that happening? Is there a better way? As you can see there in the chart there, the green. These certifications are in development. The first one is in final development, and we're having Train the Trainer here coming up in about a month, ready for next semester. So it's exciting. We're excited about the opportunities for the students.
Hey, Bill, I think we've left a couple minutes for Q&A if that's applicable.
It is, and I put a note in the chat. If folks have questions, they can put that in the chat as well, or potentially just chime in and ask the question. Here's one thing I was thinking about during the presentation: how exciting this was for those teachers that are specifically oriented around this kind of training. But as the students expand their horizons about having what you gave them is really voice and choice, right? As they start learning on their own and kind of seeking out new directions, do other classroom teachers notice that difference, and do they really want to get engaged as well?
I would say very much so, and that's the one thing. We rarely, and I know I tell the kids this, but I always quickly move on. I always say, like, without kids, we don't have a school. You guys run this place, you just don't always know it. And so we rarely tell them no when it's something that they want to try or do. Sometimes we'll say, yes, but we have to find a way to pay for that or do that. And so the choice in other classes, we've had kids create their own classes, and it's one-on-one individual development learning where they're saying, I want to learn about this form of science. And we've had several ag classes. And so to me, it's just kind of filtered into, hey, we want this too. And so the kids have that voice, and they take off and run with it. And it's we want to make this place better for my little brother or for the future. Well, that's win-win.
At the elementary school, a funny thing happened when we started including these high-tech fields, whether it's the robotics teams that we have or the 3D design and printing. There's a large chunk of the year where we have to do indoor recess at the elementary school just because the weather's bad. And teachers have started noticing that the kids were requesting during their indoor recess, hey, can we go work on programming our robot or bring it back to the classroom, or can I get on TinkerCAD because I got to finish my 3D design for this, or we need to look at our wind energy. Can we do some more testing? And so teachers started noticing this and started coming to me and be like, you won't believe it, during recess they're asking to work on learning projects instead of doing whatever else that they were allowed to during recess. So it just shows when kids are truly interested and motivated, they really will work hard, and the deep learning shows as a result.
Well, congratulations to all of you, to USD 273 and to Train. This partnership is amazing. I love the fact that it carries all the way down to the elementary level. Really, it is that kind of partnership, an opportunity to give students, as I said, voice and choice that really can transform an entire school district. It literally can do that. And so I think that's very exciting, getting to see what students getting to see what that real world of work really looks like. So thank you for that. Our next presenter is everyone.